Hello YouTubers, in this video we will talk about the electrical system and structure, or you can say the flow of electrical current in the big building from the main feeder to the endpoint equipment. First of all, we will see how these multi-story and big buildings are different from the small buildings, and what is the main difference in big buildings and small buildings. So where we feel some difference. So first we come the building load. Large building have much higher load demand, which is measured in megawatt, whereas the small building have some load up to 50 100 kilowatt, or maybe 200 kilowatt, 1000 kilowatt. In big building we require, why we require this higher load? Because big buildings, they have different purpose. Maybe it can be a hotel, it can be a residential building, it can be anything. So the higher load is required for centralized cooling plant, chillers, you can see, or other things. The other thing is exhaust air system. Centralized building have also common exhaust air system to exhaust the air from the kitchens, from the washrooms, and also the plumbing system, water supply and drainage. Firefighters fighting system also, it contains the fire engine, the main electric motor, the some jockey pumps, the other systems in the, and life safety system, which maybe contains smoke exhaust fans, makeup air fans in case of fire, many other things. And lighting, the lighting is also considered a big and different load, because you can have common area lighting, corridor, kitchen lighting, and landscape lighting, building exterior lightings, interior lightings, car parking lighting, basement lighting, utility lightings. We will make a separate video on the building lighting system. The other is dedicated transmission line. Due to this heavy load, it is not possible from the for the utility building to provide the power to this big buildings by ordinary transmission line. The ordinary transmission line is only kept for small buildings like clubs, some hotels, some cinemas, some other thing. But for the big buildings, a direct transmission line is laid from grid station or utility building to the these buildings. So these buildings they have dedicated transmission line, and they have dedicated transformer room. The other thing is level of protection. As you know, big building, there is many type of load, so there is a chance of that maybe there is a fire, maybe fire in the electrical room. There are many electrical rooms in the buildings. There is bus channel, many other things which can cause the fire. So the level of protection is also very advanced in the big buildings, and it is very necessary. Small building normally energize at the voltage level of 220 voltage, and in case of three phase, this is 440 or 415 voltage. And in some area like in Saudi Arabia, this is 110 voltage, and maybe a single phase, and 220 voltage in case of three phases. The different areas, different voltage level. In case of big buildings, multi-story buildings, as the grid station provide dedicated line, so the voltage level provided to these buildings is 11.5 kV kilovolt or 18.9 kilovolt directly from the electric supply company. So the voltage level for line which is laid between building and grid station is very high, and the dedicated and building transformers are kept to decrease the voltage, but the transformer are kept in the building own room, one separate room. We keep transformer to down the voltage level. Now, in the today's area where we are facing lot of energy high tariff rate, so more and more buildings are going to be a green buildings. There are many equipment used in the buildings to save the energy. Suppose some exhaust fans are kept off in the night times, and some parking area lights, some corridor lights are automatically off in case of certain timings. The some companies use KNX system to control the lighting. Same, the air conditioning system also go to automation but through BMS to decrease the load. So load management is a very important part in the multi-story building. Now we see that what are the components, how power flow from the building electric supply company to the in the building, and how this power flow from building transformer room to the endpoint system, which equipment we use. Now first of the equipment is the RMU, ring main unit. Ring main unit is the first equipment which is placed between the building and the utility supply company. So normally utility supply company provide two dedicated line in the ring main unit. Sometime one line is failed, or it due to some maintenance one line is kept off the RMU main unit. There is one changeover. We will discuss this thing in later on videos. So the line is shifted to other line. So this is only a changeover switch, you can see, between two line and one feeder. It has two inputs and one outputs going into the building. The other one is medium voltage switch gear. The first, the power after it comes from RMU unit, ring main unit, it is provided to medium voltage switch gear. Now medium voltage switch gear is it has two purpose. It purpose as a switching device. It can switch the it can isolate the load from one line, and it also distribute the load to many transformers. Like from ring main unit, it has one output. This one output go into the medium voltage switchgear, and the medium voltage switchgear has 4 isolators. So it will provide 5 dedicated line to 5 transformers. So we will also discuss medium voltage switchgear in later videos. Then there is come transformers. The dedicated lines comes from medium voltage switchgear to transformer, and the voltage level at this point is still very high, 18.9, 19.10 something. This depends on the country. So these transformers are the called step down transformer. These transformers reduce the voltage level from the higher voltage to the single phase 220 volt or maybe 415 volts. So the next thing is that from transformer, as we reduce the voltage from higher voltage to 415 volt, we supply this voltage to main distribution units. These are main MDB, or you can see main distribution board, or MDBs. MDBs receive the line from the transformer, one feed from transformer, and then they distribute it the current to the many circuits, sub circuits there. Now what is in front of the MDBs? Then come SMDBs. MDBs provide power to many SMDBs. These SMDBs are you can see each building floor there is one SMDB. So one MDB will provide maybe 3 floors, 3 SMDBs, and then the SMDB provide power to DBs. So suppose if one SMDB provide current to 3 floors, there is a 1 dB on there is a 10 dBs on each floor.